Chapter 3, Terminology. A group or family of the periodic table is a vertical column of elements that have similar chemical properties. Vertical columns, these are groups or families. A group has a number and a family has a name. For example, group 17 is called the halogen family. Hund's rule means orbitals of equal energy are each occupied by one electron before any orbital is occupied by a second electron, and all electrons in a singly occupied orbital must have the same spin. For example, the electron configuration of nitrogen is 1s2, 2s2, 2p3. The correct orbital notation for nitrogen illustrates Hund's rules. Nitrogen 1s, spin up, spin down, 2s, spin up, spin down, 2p, spin up, spin up, spin up, which means that each of the three p electrons goes into the px, py, and pz orbital before they start to pair up. Metals are elements that are good conductors of electric current and heat. Metals are malleable, ductile, they have a metallic luster, and are found on the left 2/3 of the periodic table. Metals tend to donate electrons. The most common oxidation number of metals are +1, group 1 for example, +2, group 2 for example, and +3. Metal reactivity increases down the chart from top to bottom and to the left. The most active metal on the table is francium. Metals are in dark blue in the table. Metalloids are also called semimetals. The metalloids form a staircase on the periodic table and are labeled with a red triangle in the table and a yellow-colored background on the periodic table in the picture. So they make a staircase. The reactivities of the metalloids depend on the element with which they are reacting. For example, metalloids behave like a metal when they react with a nonmetal. Nonmetals are elements that are poor conductors of heat and electricity. Nonmetals are brittle. Nonmetals are found on the right 1/3 of the periodic table. They're colored dark green on the table. Noble gas configuration is electron configuration for an element where the outer main energy level fully occupied, in most cases, by 8 electrons. Helium is the exception. Helium only has 2 electrons. Elements in group 18, that's this last vertical column, are called noble gases. For example, the electron configuration for neon is 1s2, 2s2, 2p6. The orbital notation for neon is 1s, spin up, spin down, 2s, spin up, spin down, 2px, spin up, spin down, 2py, spin up, spin down, 2pz, spin up, spin down. The dot notation, the outer shell configuration, involves only the second level electrons. There are 2 electrons in the second s sublevel and 6 electrons in the second p sublevel, for a total of 8 electrons, 8 dots, which is what they called an octet in the outer shell. In the exemplar above, the electrons in the p sublevel spread out. Notice they spread out where they can. So they spin up until they can no longer spin up. There's the px, a py, pz. There are 4 electrons in the 2p for oxygen. Spin up, spin down, spin up, spin up. The periodic law states elements with similar chemical properties occur at regular, i.e. periodic intervals, when the elements are arranged in order of increasing atomic numbers. For example, elements in a group or family have similar properties. Elements in group 1, the alkali metal family, are silvery active metals, have one electron in their outer shell, and have a +1 oxidation state. A period of the periodic table is a horizontal row on the periodic table. There are 7 periods, and the numbers are down the table. A representative element is an element in which the distinguishing electron is found in the S, these first 2 columns, or the P, groups 13 through 18. The representative elements are colored green in this table. Transition elements are elements in which the distinguishing electron is found in the d orbital. Transition elements are groups 3 through 12, and they are colored orange in the table. Finally, the inner transition elements are the elements in the lanthanide, this horizontal row, and the actinide series, this horizontal row. The inner transition elements are colored pink in this particular table.